we have a table, and the number of passengers who have boarded the ship is modeled from the differentiable function p, where t is the number of hours since boarding began. The values of p of t for the selected value of t are given in the tables above. So over time, we are getting more passengers. So after at 0 hours, there are 0 passengers. At 1 hour, there are 35. At 3 hours, there's 204. 6 hours, there's 600, and then at 8 hours, there's 728. Okay. According to the model, what is the average rate at which passengers board the ship in passengers per hour over the time interval 1 to 8? So we are looking at 1 to 8. So we need f of 1, which is 35. We need f of 8, which is 728. And then to find the average rate of change, we're going to do f of 8 minus f of 1. That should be a 1, not a 5. 1 over 8 minus 1. And this would be our slope. So substitute our numbers in. So we're going to do 728 minus 35, use substitution, and then 8 minus 1, still a slope. When we calculate that, that should be 693, if I did the math correctly. I don't know, eyeballing it. So we would do that would be a 6. I guarantee you that's a 6. Then 12 becomes a 9. And then 8 minus 5 leaves us 3. Okay, over 7. Now, can this be simplified? So let's do 693 divided by 7. So 7 goes into 69 times, right? 72, 81, 63. Okay, 63. That gives us a 63. And then 9, 63 gives us a 0. So then our slope becomes 99 passengers per hour. That is the average rate that passengers are boarding this boat, I think, or ship. So according to the model, what is the average rate of passenger from 1 hours to 8 hours? So you should probably include the interval with that answer as well. So if this was an open response, you might say that the average rate of change from 1 to 8 hours is going to be 99 passengers per hour, and then provide the work that's given, and you should be good to go. Man, that seems really big. Let's try that. All right, on to the next one. Okay, so write p prime of 4.5 as a limit of a difference quotient. Use the data in the table to approximate p prime at 4.5. Show the computations that lead to your answer. So if we're going to do this, remember, this prime is going to be the slope of tangent at x equals 4.5. Yeah, swear.
Look, I found.
What did you find? Ooh, you found the Ghostbusters trap. Yeah, that's awesome. Sweet.
I can open it.
Yeah. Can I keep working?
Yeah.
Okay. So we need the slope of the tangent at x equals 4.5. So can we find the slope of the tangent at that value? Not really. But what do we have? We've got 3. And we've got 6. And what's in between 3 and 6? Well, there's 4.5 there somewhere. So let's find the average rate of change, which is approximately the instantaneous rate of change, right? So we will do f of 6 minus f of 3 over 6 minus 3, which in turn will become 600 minus 204 over 6 minus 3. That would be 396 over 3. Prime will be 132 passengers per hour. So write P prime 4.5 as a limit of the difference of quotants. So use the data in the table to approximate 4.5 and show the computations that lead to your answer. So the difference of quotants is doing what we are doing here. We're showing that we can find the average rate of change by going in between 4 and 3. Or, excuse me, 6 and 3. Yeah. I don't know. I don't think there's really anything else we need to do. I want to check the solution just to make sure we are on the same page. First one was 99. The average rate at which passengers board the ship over the time interval 1 to 8 hours is 99 passengers per hour. We were good on that. Oh, we needed to do the limit. Man, I screwed that up. Oh, wow. Okay. Bummer. Yeah. Wondered about that. So this was our approximation. We definitely did that, but we needed to do... Bummer. Screwed up. We needed to show that P prime of 4.5 is equal to the limit. And you have a couple different limits. We had the one where x approaches a, f of x minus f of a over x minus a. Or we have the limit as h approaches 0 of f of a minus h minus f of a all over h. And instead of a, obviously we need to use 4.5. So you needed to utilize one of these two. So that's when it says right here, write it as a limit of a difference of quotants. Dang. And it even tells you limit. I knew I was missing something. That's why I wanted to check. So how are you supposed to know? Well, I mean, it did tell us to use a limit, and then I should have made the connection to the derivative and our two limits that give us the derivative. So that's where I made my mistake. So then with this, just replace the a with the 4.5s because it just says write it, and then use the data to approximate. So at that point, you have to kind of throw these out the window and then go back to this because it's sort of a different idea altogether. Interesting though. All right. On to the next. There must be a time t for 3 to 6 hours at which p of t equals 500. Justify your answer. All right. If your brain isn't saying IDT yet, it needs to be. Intermediate value theorem. Intermediate value theorem. In intermediate value theorem, the first rule of the IVT is it must be continuous. Don't No, if it's, let's go back to the original problem because I'm curious on what this says. Show all your work, unless otherwise specified, simplified decimal approximations, unless otherwise specified, the domain of the function f, all real numbers. Number of this, values p of t. So, right, p prime as the limit of different quotients. Huh. I don't see anywhere where it tells us that it's differentiable. And you're like, well, why do I care if it's differentiable? Well, differentiability implies continuity. And I would say because B says that we are approximating the derivative, that it is differentiable. So because part B, we are approximating, therefore P of T is differentiable. So now that we've implied continuity, which you need to, because at some point we have to go across the roller coaster. In Mario, at some point, if we're starting at 3, which is at 204, and we're going to 6, which is at 600, if it's continuous, no matter what route we take, we could go like this, we could go like this, we can go like this, straight across. Whatever we're doing, at some point in this process, we have to cross 500. We have to cross 500 at some point. So that's what the IVT uses, and that's what we're trying to justify when we do this. So we want to say interval is from 3 to t to 6, and f of 3 is equal to 204. F of 6 is equal to 600, and F and 204 is less than 500 and is less than 600. Therefore, F of 3 is less than or equal, and we can put equals, I guess, 500, 600. Oh. F of 6, and you could even put F of C here if you're looking for this. Therefore, 3 is less than C is less than 6. Because we're looking for when F of C equals 500. And if we look at the solution they give us over here, I'm curious on student's response accurately, P is continuous with reason. So what is the reason they're going to give? Because P is differentiable, P is continuous. But where does it say P is differentiable? That's the problem. That's where I find something interesting. So P of 3 equals 204 is less than 500 is less than 600, which equals P of 6. By IVT, there must be at least one time t in between 3 and 6 such that P of t equals 500. So maybe we need to write a statement here at the end using IVT. I don't know if IVT at the top is enough for the AP people. Hopefully it is. I mean, if you were to write this as your solution, I don't know. I would have a tough time for them not to accept this. What I don't accept is where does it say it's differentiable? That's what I'm curious about. And this is the problem right here. Show all your work, even though the question may not explicitly remind you to do so. Clearly label any functions, graphs, tables, or other objects that you use. Justifications require that you give mathematical reasons and that you verify the needed conditions under which relevant theorems, properties, definitions, and tests are applied. Your work will be scored on correctness and completeness of your methods as well as your answers. Answers without supporting work will usually not receive credit. Unless otherwise specified, numbers, numeric or algebraic, need to be simplified. If your answer is given in decimal approximation, it should be correct to 3 decimal places. Unless otherwise specified, the domain of a function f is assumed to be the set of all real numbers x, for which f of x is a real number. Then it gives us this table. The number of passengers who board a ship is modeled by the differentiable function p. Okay, sweet. That does say it's differentiable. Oh, whew, that makes my heart happy. So it does say that it's differentiable. So therefore, differentiability implies continuity. So we can do this, and we don't even need this because it tells us that it's differentiable in the original problem. So differentiability implies continuity, which is given, what I would do, which is given, which is stated. Let's do it. Problem states that it is differentiable. I know my handwriting's terrible. And differentiability implies continuity. So P of t must be continuous. And then maybe by IVT, make sure you spell it out, intermediate value theorem, don't shorten it with IVT. I'm doing that because I don't have space. By IVT, f of 3 is less than f of c is less than f of 6, 204 is less than 500 is less than 600. Therefore, our c value exists between 3 and 6. Hey, excuse me. That should be sufficient enough for a perfect score. All right, last one. The total number of gallons of water used by passengers on a ship is modeled by G of t. All right, so G of t. And if I were doing this problem, I really would write myself a note of what G of t actually is. For 0 to 8 hours, where t is the number of hours since boarding, find G prime of 4, the rate at which passengers use water in gallons per hour at t equals 4 hours. Okay, so I am going to look at t to the 3/2 power. If you want, let's see if we can work it both ways. The first times the derivative of the second plus the second times the derivative of the first. 4 times it by 3 halves. So we're going to do 120 times it by 3 halves t to the 1 half. Now, we can work all of this out if we need to, but at the end of the day, we are plugging in 4 hours. So before you get too ahead of yourself, you're looking for g prime at 4. So 120 times 4, I can do that. 1 half times 1 over the square root of 4. You got to know your basic skills. That's a little bit of a history lesson. But if it's a negative exponent, you take it from the upstairs, move it to the basement, or if it's in the basement, move it up to the upstairs. So when you have a negative exponent, it just changes whether it's in the numerator or the denominator. Excuse me. If whether it's in the numerator or denominator. If it's already in the numerator, put it in the denominator. And then let's look at 120 times 3 over 2. And I'm looking at this from a sense of like a non-calculator question, which this very well probably is. I could take 120, cut it in half. So then that's 60. And then that gets rid of the 2 in the bottom. The square root of 4 is a 2. And now I'm doing 60 times 6, which 6 times 0 is 0. 6 times 6 is 36. And we should get that. Now, I don't know, but I'm hoping 2 times 120 is 240. This is what, 480? Cut in half, and then cut in half again. So let's see if that works. So cut that in, that's 240 times another half, plus a 240. That's a 120 plus 240, which equals 360. Okay, so look at that. You can use product rule or simplify the expression first and then just do a power rule and you will get the same solution. So find g prime at the rate at which passengers use water in gallons per hour. So this is gallons per hour. Gallons per hour. Make sure you label it. At t equals 4. Sometimes stating that at the end, writing a statement at the end, is very helpful for them to see and recognize. Yeah, see, look. At time t equals 4 hours, passengers use water at a rate of 360 gallons per hour. So writing that statement is, I want to say, pretty important. I would highly, highly suggest writing that statement. And what does it say? Just, no, giving me g prime at t and g prime at 4. Yeah, I don't know. They give us g prime at 4. Making sure it's labeled, though. I definitely would stress a lot to write that statement at the end. I think it's extremely important. But if you have any questions, feel free to reach out. Please don't hesitate. Join Discord, write comments in the YouTube video, whatever you want. I hope you enjoyed this video. Plenty of social media out there to join. But nothing else, check out our Discord. There's a lot of cool stuff in it. And that will do it for Math Dragon Tutoring. Till next time. See you later.